When we dream of science, we often imagine a fortress of knowledge, a place of absolute certainty. We picture a grand structure built from unbreakable truths, where every fact is tested and every law is proven. This is the dream of exact science. It promises not just understanding, but control. Control over the forces of nature, over disease, and over the chaos of the universe. It offers a kind of power that humanity has always craved. With this power, we imagine we can build a better, safer world. We see a future where our most pressing problems are solved through logical, repeatable experiments. The allure is immense. It is a vision of a world free from the shadows of ignorance and fear, illuminated by the bright, steady light of reason. This vision extends beyond just practical power. It speaks to a deep human need for peace of mind. In a world that often feels random and unpredictable, the idea of an underlying order is incredibly comforting. Exact science seems to offer this order on a silver platter. It suggests that if we just dig deep enough, we will find a set of fundamental rules that govern everything. From the dance of distant galaxies to the intricate workings of a single cell, there is a blueprint we can aspire to read. This promise of ultimate clarity can feel like a spiritual quest in itself. It's the hope that by understanding the cosmos, we might finally understand our place within it, finding a sense of security in the beautiful, predictable machinery of reality. The dream of exact science is also a dream of objectivity. It imagines a world where our personal biases, our emotional whims, and our cultural beliefs can be set aside. We can arrive at truths that are universal and valid for everyone, everywhere. Think about the law of gravity. It works the same whether you believe in it or not. This is the strength of science. It builds a common ground for all humanity. In this shared space, disagreements can be settled not by opinion or authority, but by evidence. This objective framework promises a way to move beyond endless disputes and build a global society based on verifiable facts, a powerful and inspiring goal for a species so often divided by its own subjective experiences. Ultimately, the power of this dream lies in its promise of finality. We yearn for a day when the book of knowledge is complete, when all the great mysteries have been solved. It is the desire for an end to the struggle, a final destination for our relentless curiosity. We imagine a future where we don't know is no longer a common refrain. This ideal of a complete and finished science represents the pinnacle of human intellectual achievement. It is a testament to our species' ability to look at a vast and bewildering universe and not shrink away in fear, but to instead roll up our sleeves and attempt to figure it all out, piece by painstaking piece. This bold ambition is, in itself, one of the most remarkable things about us. For some, the dream of exact science became so powerful that it started to look like a replacement for older systems of belief. As our understanding of the natural world grew, the explanations offered by traditional religions began to seem less necessary. Where once people saw the hand of a divine being in a thunderstorm or a harvest, they now saw the predictable workings of atmospheric pressure and biology. This shift led many thinkers to wonder if science could offer a complete guide for life. Could this new, evidence-based worldview provide not only explanations, but also meaning, ethics, and a comprehensive philosophy to live by? It was a bold and exciting question for a modernizing world. This idea gave rise to philosophical movements that sought to build an entire worldview based solely on scientific principles. One such movement was known as monism. Its followers believed that everything in the universe, from rocks to human consciousness, could be explained by a single, unified set of natural laws. They saw science as the one true path to enlightenment. For them, the scientific method was not just a tool for discovery. It was the foundation for a new, rational creed. This new religion of science would be free from superstition and dogma. It would be a belief system for the modern age, grounded in tangible proof and logical deduction, promising a world governed by reason instead of faith. The appeal of this idea is easy to understand. A worldview based on exact science promises a kind of intellectual purity. It suggests we can shed the baggage of ancient traditions and build our understanding of reality from the ground up, using only what we can observe and measure. This approach feels clean, honest, and uniquely empowering. It places the ultimate authority not in an ancient text or a priestly class, but in the hands of every individual capable of reason and observation. It is a deeply democratic ideal, suggesting that anyone can access the truth if they are willing to follow the evidence. This vision of a world guided by shared, verifiable knowledge remains incredibly attractive. However, the hope that science could become an all-encompassing philosophy ultimately fell short. Movements like monism faded because science, for all its power, has limitations. It excels at answering questions about how the universe works, how planets orbit the sun, how DNA replicates, but it struggles to answer questions about why. It cannot, by its very nature, provide a universal moral code or tell us the ultimate purpose of our existence. Science can describe the intricate beauty of a sunset, but it cannot tell us why we find it beautiful. This is not a failure of science, but a recognition of its proper domain. It is a tool for understanding the physical world, not a complete manual for the human spirit. The grand dream of exact science rests on a simple, powerful idea: that its knowledge is built upon an absolutely solid foundation. We imagine it like a skyscraper, with each new discovery resting securely on the proven facts that came before it. This image gives science its authority. We trust it because we believe it is anchored in something unshakable. For centuries, philosophers and scientists have searched for this ultimate cornerstone. They looked for a single, universally valid principle, a starting point so obviously true that no one could possibly deny it. From this one truth, they hoped, the entire edifice of science could be logically constructed, making it immune to all doubt and skepticism. This quest for a perfect foundation proved to be far more difficult than anyone imagined. Great thinkers dedicated their lives to the problem, proposing various starting points. Some suggested that pure logic or mathematical axioms could serve as the base. Others argued for innate ideas that all humans are born with. Yet, for every proposed foundation, another thinker would find a crack, a flaw, or a reason to doubt it. No single principle has ever been found that could be established, that is, before experience, and be accepted by everyone as the absolute, undeniable truth. The solid bedrock that everyone was searching for seemed to be more like quicksand. This failure to find a universally accepted starting point led to frustration, and, for some, a deep sense of disillusionment. If science could not prove its own first principles, how could it claim to have a special hold on the truth? This nagging uncertainty created a vacuum. Some people, disappointed by the limits of pure reason, turned towards skepticism, concluding that perhaps no real knowledge was possible at all. Others, seeking the certainty that science couldn't seem to provide, looked for answers in alternative belief systems or mystical philosophies. They sought refuge in creeds that offered the absolute, unwavering foundation that the scientific world, for all its rigor, had failed to deliver. The dream of a perfectly logical, self-contained system of knowledge seemed to be slipping away. This reveals a fundamental, and perhaps surprising truth about science. Its magnificent structure is not built on a single pre-proven cornerstone of absolute metaphysical truth. Instead, its strength comes from something else entirely. Science is powerful not because its foundation is perfect and eternal, but because it is willing to constantly test and rebuild that foundation in light of new evidence. It doesn't start with an unshakable answer. It starts with a humble question. The realization that science lacks an absolute foundation is not a sign of its weakness, but the very source of its incredible resilience and its capacity for endless growth and self-correction. There is a popular idea that true science must begin with a completely blank slate. This is the concept of science without presuppositions. It suggests that a scientist should approach their work without any preconceived notions, assumptions, or beliefs, allowing the facts to speak for themselves in a completely pure and unfiltered way. This sounds like the ideal of perfect objectivity. It's a noble goal, to be sure. The problem is, it's impossible. All thinking, including scientific thinking, has to start somewhere. You cannot build an argument or a theory out of thin air. you need some kind of raw material to work with, some initial point of contact with the world. For centuries, the search was on for a perfect, abstract starting point, a logical principle that could kickstart all of knowledge. But as we've seen, that search was fruitless. The great thinkers of history could not agree on a single, self-evident truth to begin with. So, if science cannot begin from a purely logical or metaphysical principle, where does it begin? To build a system of knowledge that can resist even the most determined skepticism, we must turn to the one thing that is absolutely, undeniably real to each of us: our own direct experience. The foundation of all science is not an abstract idea, but something much more personal and immediate. It is the world as delivered to us by our senses. Think about what you can be truly certain of. You can be certain of the colors you see, the sounds you hear, and the textures you feel. These are your sensory impressions. Now, your interpretation of these impressions might be wrong. You might see a pool of water on a hot road, only to realize it is a mirage. The sensation of seeing the water was real, even if the water itself was not. This is the crucial distinction. The raw data from your senses, the sense world, is the only thing that is completely incontestable. It is your private, subjective, yet unassailable starting point. This humble personal experience is the bedrock upon which the grand, objective edifice of science is ultimately built. This means that science does not begin in a sterile, abstract void. It begins in the messy, vibrant, and deeply personal world of human sensation. It starts with the simple act of looking, listening, and touching. This is not a weakness, but a profound strength. By grounding itself in direct, verifiable experience, science ensures that it never drifts too far into pure speculation. It remains tethered to reality as we perceive it. The myth of starting from nothing is replaced by the powerful reality of starting from something very specific. The rich and colorful tapestry of sensory data that makes up our conscious experience of the world. This is the true raw material of all knowledge. The process of building a scientific worldview begins not in a laboratory, but in the crib. Consider, for a moment, a small child. Their world, at first, is really just a chaotic flood of disconnected sensations. A flash of red, a sudden loud noise, the feeling of a soft blanket, the taste of milk. These are just raw sense impressions, a sort of kaleidoscope of experiences without any apparent order or connection. The primary task of a developing mind, and, in a more refined way, the primary task of science, is to bring order to this chaos. It's really the process of taking this jumble of sights, sounds, and feelings, and weaving them into a coherent and predictable picture of reality. This, I would say, is where the journey to knowledge truly begins. The engine that drives this process is wonder. Imagine a child shaking a rattle. They see its shape, feel its texture, and hear its sound. At first, these are just separate events. But, pretty soon, the child notices a pattern. Every time they perform the action of shaking, a tactile and muscular sensation, the rattling sound, an auditory sensation occurs. This connection is, in a way, a small miracle. It is the discovery of a law of nature, a predictable relationship between different sense impressions. This moment of discovery, this spark of wonder at the orderly connection between things, is really the birth of scientific thinking. It is the realization that the universe is not just random noise. It has a structure that can be understood. From these simple beginnings, the child slowly constructs a practical world picture. They learn to group consistent clusters of sensations together and label them as objects. The rattle is no longer just a collection of visual, tactile, and auditory data. It becomes a single thing, a rattle, which is understood to be the of those sensations. This is, honestly, a monumental intellectual leap. It is the creation of a real world of objects that exist independently of our immediate perception. This world picture allows the child to navigate their environment, make predictions, and survive. It is a model of reality, built piece by piece from the raw material of sensory experience and the logic of cause and effect. This childhood process is, in fact, a perfect microcosm of the scientific endeavor itself. Science does the exact same thing, just with far greater precision and sophistication. It takes the sense data from the world, whether from the naked eye or from a powerful particle accelerator, and seeks to find the orderly interrelations, the underlying laws that govern them. Everyday reasoning is gradually refined into the rigorous logic of mathematics. The naked eye is enhanced by microscopes and telescopes. But the fundamental impulse remains the same: to move from the chaotic world of disconnected sensations to an ordered, unified, and understandable world picture. The wonder that a child feels at a rattle is the same wonder that drives a physicist to uncover the laws of the cosmos. As we grow from a child into an adult, and as humanity grows from an ancient civilization into a modern one, our picture of the real world does not stay the same. It constantly evolves. The practical world of objects that a child builds is a simple but effective model. For early scientists, the model became more sophisticated. The real world for classical physics, for instance, was imagined as a universe composed of a finite number of fundamental building blocks. For a long time, this meant the 92 naturally occurring elements of the periodic table. These atoms were thought to be indivisible and eternal, the permanent bedrock of reality. All the complexity we see around us was just the result of these atoms combining in different ways. This picture of reality was incredibly successful. It allowed scientists to make tremendous progress in chemistry and physics. It was a clear, intuitive, and powerful model. But science is a restless endeavor. New experiments and observations, made possible by new technology, began to reveal phenomena that the simple atomic model could not explain. The discovery of radioactivity, X-rays, and the electron showed that atoms were not indivisible after all. They had an internal structure. The real world of classical physics had to be abandoned, not because it was wrong, but because it was incomplete. The face of reality, as understood by science, was forced to change. Today, the real world of modern physics looks very different from the clockwork universe of atoms. The fundamental components are no longer 92 immutable elements. Instead, reality is defined by a strange and wonderful new cast of characters. Particles like electrons and protons, universal constants like the speed of light, and the bizarre rules of quantum mechanics governed by the quantum of action. This new picture is far less intuitive. It is a world of probabilities, wave-particle duality, and interconnected fields. It was not a picture anyone chose. It was a picture that was forced upon us by the relentless accumulation of experimental evidence that simply did not fit the old model. This process of change might seem to suggest that science is just stumbling around, lurching from one incorrect theory to another. But that is not the case. This evolution is not a random zigzag. It is a clear progression. Each new scientific world picture incorporates and explains everything the old one did, and more. Newton's laws of gravity are still perfectly useful for sending a probe to Mars, even though we now have Einstein's more comprehensive theory of general relativity. The shift from the classical world of atoms to the quantum world of electrons represents a journey from a more naive, common-sense understanding to a deeper, more unified, and more powerful description of reality. Science is always moving forward, ascending toward a more complete view. The constant evolution of the scientific world picture points toward a singular, ultimate goal. This goal is the driving force behind the entire scientific enterprise. It is the quest to identify the final, immutable elements of reality and the universal laws that govern them. Science is essentially trying to create a perfect map of the universe, one that is complete, consistent, and accounts for every single phenomenon we can observe. This ultimate picture is what we might call the metaphysical real world. It is the objective, final, and absolute truth that exists independently of our minds, our theories, and our measurements. It is the thing that our ever-changing scientific models are trying to approximate. This goal, however, is a very special kind of goal. It is a destination that science constantly strives for, but can never definitively prove it has reached. How would we ever know if we had discovered the final theory of everything? There could always be a new phenomenon, hiding just beyond the reach of our current instruments, that would force us to revise our understanding once again. Therefore, the existence of this ultimate, objective reality is not something that science can prove. It is something that science must postulate or assume in order to function. It is a guiding star that gives direction and purpose to the journey of discovery. This might sound like a strange paradox. Science, the discipline we associate with hard proof and evidence, is based on a foundational assumption that cannot itself be proven. The scientist must have faith that there is a consistent, understandable, and unified reality out there to be discovered. This is not the faith of Christianity, which is based on the Bible. It is a different kind of faith, a faith in the possibility of knowledge, a conviction that the universe is not an unsolvable, magical mess. This postulation of an ultimate reality is what saves science from being just a random collection of facts and transforms it into a unified, progressive search for truth. This metaphysical real world is not some spooky, supernatural realm existing behind the world we see. It is not separate from the world of phenomena. Rather, it is the underlying structure within it. It is the deep grammar that governs the language of the cosmos. The scientist's job is to decipher that grammar by studying the sentences, the phenomena we observe with our senses and our instruments. The assumption is that a coherent grammar exists. This necessary premise is the engine that drives science forward, pushing it to create ever more unified and comprehensive models of the world, even if the final, perfect model remains forever on the horizon. We have arrived at a crucial point in our journey. On one side, we have the world of our senses, the vibrant, chaotic, and subjective realm of colors, sounds, and feelings. This is the world of phenomena, the undeniable starting point for all knowledge. On the other side, we have the postulated metaphysical real world, the objective, unified, and ultimate reality that science aims to describe. Between these two worlds, there lies an unbridgeable chasm. We can never leap from our direct sensory experiences to the final objective truth in one single logical step. The path between them is the long, winding, and never-ending road of scientific inquiry. This gap exists because our scientific models of reality are always constructed, not directly perceived. Think of the concept of an electron. No one has ever seen an electron in the same way we see a table or a chair. An electron is a theoretical construct, a mathematical model. It is a powerful and incredibly useful idea that helps us explain a vast range of sensory data, from the light of a fluorescent bulb to the behavior of a semiconductor. We infer the existence and properties of the electron from the measurements we make and the patterns we observe. We are forever stuck on the side of phenomena, using our intellect to build bridges of theory toward the unseen shore of ultimate reality. This unbridgeable gap represents what we might call an irrational element at the very heart of exact science. Irrational here does not mean illogical or nonsensical. It simply means that the leap of faith required, the assumption that a real, objective world exists and is responsible for our sensations, cannot be justified by pure logic alone. It is a foundational premise that we must accept in order to get the whole project of science off the ground. Science, in its profound honesty, must admit that it cannot eliminate this fundamental assumption. It is a self-imposed limitation, a recognition that its reach is not infinite. This inherent limitation is not a sign of failure. It is, paradoxically, one of the greatest strengths of science. By acknowledging this chasm, science remains humble and self-critical. It understands that its theories are not the final word, but are instead the best possible maps of reality we can create at any given time. This constant tension between the world we experience and the world we postulate keeps scientists on their toes. It forces them to constantly test their assumptions, refine their theories, and search for new evidence. This acknowledgement of an ultimate mystery at its core is what makes the scientific method so reliable and robust. It never claims to have the final answer. So, where does this leave the dedicated scientist? If the dream of absolute knowledge is unattainable and the final truth is forever beyond our grasp, what is the point of the struggle? The answer lies not in reaching the destination, but in the journey itself. The scientist is confronted with a profound duty to tirelessly explore everything that is explorable, to push the boundaries of our understanding with every tool and every ounce of intellect they possess. Their task is to map the shores of the known world with as much precision and honesty as possible. This is the core of the scientific endeavor, a conscientious and rigorous performance of one's duty to knowledge. At the same time, the scientist must learn to stand in humble awe before that which remains inexplorable. They must honor the vast ocean of mystery that extends beyond the shores of our current understanding. This is not an admission of defeat, but an act of profound intellectual integrity. It is the recognition that the universe is larger than our capacity to fully comprehend it. The great German writer Goethe once said, "The greatest happiness of a thinking man is to have explored the explorable and to quietly venerate the inexplorable." This beautiful sentiment captures the true spirit of science perfectly. It is a balance between relentless curiosity and profound humility. The ultimate reward for a life in science, then, is not the prize of absolute certainty. That prize does not exist. The truest reward is something more personal and more noble. It is the inner satisfaction that comes from having contributed a stone to the great edifice of science. It is the quiet peace of mind that comes from knowing you have performed your duty with integrity, followed the evidence wherever it led, and been honest about the limits of your knowledge. This pursuit of truth, carried out with honesty and humility, cultivates an integrity of soul that is more valuable than any single discovery. In the end, the dream of exact science is not about eliminating mystery, but about learning to live with it gracefully. It is about the joy of discovery, the thrill of seeing a small piece of the cosmic puzzle click into place. It is about the shared human adventure of looking out into the vast darkness and lighting one small candle after another. The happiness of the scientist comes from this noble work, from exploring the explorable with rigor, and from honoring the great, beautiful, and enduring mystery of what lies beyond. This, perhaps, is the most profound knowledge of all.